I'm Professor Brad Fulton, and welcome to my Stats podcast. This is an edited audio recording of my course. Each lecture is its own episode, and there's a total of 24 lectures. This course provides an introduction to the quantitative methods social scientists and data analysts use to collect and evaluate empirical data about society. Through this course, you will learn to gather, describe, and analyze data with an emphasis on the application and interpretation of these methods. This course will also help you to be a more informed and critical reader of academic research, public opinion polling, and advertisement claims that present statistical evidence. Although some of the current events I reference might be dated, the content is timeless. I hope you enjoy this lecture, and if you have any questions, you can email me at bradrfulton@gmail.com. Hi, my name is Professor Fulton. If you like this podcast, you'll love the book I use for the course. It's titled Statistics: Unlocking the Power of Data. This book uses a highly intuitive approach to help students visualize statistical concepts, which accelerates understanding. I've reviewed dozens of textbooks, and Unlocking the Power of Data is hands down the best one out there, mainly because of its unique intuitive approach and straightforward explanations. You can find a link to the textbook in the show notes, and if you use the promo code BLOCK5, you'll get a 10% discount. Air pollution is higher in places with a higher proportion of paved ground relative to grassy ground. Give a confounding variable that may help to account for this association. The answer you gave was what? Do you remember?
Alright, the reason why it's probably more polluted than like the grassy area is industrialized.
I said like more cars pass through paved roads, which would create more pollution because not many cars will go through grass.
Yeah, they're being kind of vague. What's the variable that they're measuring? They're measuring air pollution, and then what's the other variable that they're looking at? What's the characteristic of the community that they're measuring?
Paved or grassy.
Paved ground or grassy ground. So yeah, that's where they're being kind of vague. It's sort of like the proportion of roads in the community is associated with the amount of pollution in the town. And so what they're really saying is if you have a lot more driving going on, a lot more cars, probably in an urban area or an industrialized area.
That's how I answered.
Yep. So you answered correctly.
Yeah, I guess because the question was so simple, I kept over.
Yeah. So, and I think in general, what's important to understand is someone might be claiming here's an association and this is causing this. Mm-hmm. And as sociologists and statisticians, we need to be able to say, well, what are other variables or other factors that might be causing this or associated with this that they're not taking into account? So it's basically to get you thinking, what are the other factors that they're not really accounting for? Okay, then with part 2, I'll have each of you share one of the variables that's associated with one of your original variables and explain why you think that it could be a possible association. So we'll start with Chelsea in the back.
I think one was suicide.
And
it had to do with the person that was like bankrupt, and then went bankrupt, committed suicide, and then the person just didn't feel like living anymore. But I feel like it was associated because the person didn't feel like living anymore. Maybe it's.
So, and what is the suicide question?
One of them is whether you think it's okay for someone to take their own life because they're bankrupt or something like that.
Oh, okay. Brittany?
On for the abortion, like if you think it's okay to have an abortion, I thought like the sex of the person who's answering it.
Very good.
Want to actually have abortion.
Yeah, that's very good.
I think one of them was who voted for like Obama and McCain. I said, and I did the one with like the father's income.
Oh, okay.
Like whatever someone's income was, who they voted for.
So is income associated with whether you vote for Obama or McCain? So in the GSS, it has a question of who you voted for in the presidential election, I guess? Or?
It was like Prezo 8.
Okay, Prezo 8. Okay, great. Tim?
The question I had from previous assignment was like about income. Which groups did your family income from all sources fall last year before taxes? And I just associated with like this one called Earn RS. It's just like think about your family now. There's people in your household who are related to you. How many persons in the family, including yourself, earned money from last year.
Oh, okay.
Whatever. So like the variable obviously that's just income.
Yeah.
And they're associated because all these people either worked before or are currently working.
Uh-huh.
And they're just trying to like see how much income there.
So if you have more people in the household who are earning income, would that be associated with a higher income? Overall income is what you're saying?
Yes, sir.
Yeah, that's good. Okay.
I don't have the second variables.
Oh, okay. That's right. She had internet ills, so. Well, you can still think of one. Pick one of your variables and make up a variable that you think is associated. Yeah, I'm not going to let you get off that easy.
One of the variables was, have you ever tried to give up smoking?
Uh-huh.
And you could look at their age.
Oh, okay. Yeah, that would be good. And what would you think, explain why you think there'd be an association?
I feel like if you were older, it'd be harder to quit.
Mm-hmm.
Because you'd be more addicted to it.
Yeah, it also depends on how long you've been smoking,
right.
too. So yeah, that's good. McKay she found an interesting variable, grass, which I thought was funny. Or that's the name of the variable, and then it's, have you used marijuana or something like that?
Yeah.
So, but I actually know the people who name these variables, and they're just faculty at universities around the country. And so, and whenever they come up with a new variable, they need to create a variable name for it. And so I bet you at some point they have fun thinking, oh, this would be a fun name. Some of them are just random and just kind of weird. And they don't really even make intuitive sense, but some then are like, oh, that's good, I'll remember that one. So, okay.
What I had was about the single parents and whether they can raise kids as good as one.
Uh-huh.
And, as good as two.
Yeah.
And I thought another variable could be like their income and like if they could support.
So this would be, the respondent was asked, do you think single parents can raise kids just as well as two-parent households? And then you look at the income. Now, is the person who's answering, are they a single parent?
Yeah.
Okay, but it might not be, because the question is just more of an attitude or belief question.
Yeah.
So, and that's an important thing to look at. And that's why sort of we look at the actual question to see, is this talking about a person who's a single parent or just your beliefs about single parenting? And even like with income, that's an important one to look at, because there's probably like 20 different income variables. Some is like, what is your income in the last year? What is your income in real dollars, which accounts for inflation? What's your household income? And then there's one I looked at, it's like income, and I looked at the mean income value, and it was like $25,000 or something. I was like, that's just not right. And then I looked at it, and you look at the different categories of options, and it only went up to 25,000, and the last category was 25,000 or more. And so, anyways, as we go down this path, you'll want to sort of scrutinize your variable to make sure that it's measuring what you think it's measuring. Because just because it says income doesn't necessarily mean it's the type of income that you're thinking about. But that's good. I'm glad you guys are introducing me to new variables. There's obviously tons of variables in there, so you're finding good ones. Today's lecture is focused on describing data. To me, this is probably one of the, more interesting sides of it, because you actually get to see what's going on with these variables of interest. Like, what proportion of people think that single parents can raise a kid just as well as two parents? So all these variables, you're kind of like, well, it's a really interesting question, but what is reality? What's the general proportion in the U.S. population who falls in this camp versus this camp? So the two types of variables that we've been looking at throughout are categorical variables and quantitative variables. Those are the two types of variables that you'll ever be working with, at least in this course. And there's different ways of describing those two variables. But first, just look at the big picture. Again, we have population. What's the letter that represents population? Capital N. Good. And then we do what type of sampling do we do from the population? Random sampling. Excellent. So we do a random sampling. So we get a sample that's reflective of the population, and then from the sample we can make inferences about the larger population. And so the first step when we get a sample is called exploratory data analysis. And you guys have already been doing this by just grabbing variables and beginning to explore what's the variable question, what are the different responses that they can give. But then we're going to move into a more quantitative exploration of the sample. And the field is called descriptive statistics. And the purpose of it is to make sense of the data. We need to summarize and visualize it. And so with like income, let's say, you want to be able to look at all the different values and sort of summarize what the values are. Like, what's the range of the values, what's the maximum value, and also there's ways to visualize it by charting it or doing pie charts or bar graphs and things like that. Again, it goes back to exploratory data analysis. You're exploring the data, just finding out what's there, what's reality. The types of statistics that you get depend on whether it's a categorical variable or a quantitative. And so I'll walk you through those two pathways, like one for categorical and one for quantitative. For example, I'm going to take my own research. For my dissertation, I'm looking at community coalitions throughout the country. And these are coalitions of community organizations that work together. So let's see, right here, Durham, North Carolina is right there. And there's a group called Durham Can, which is a coalition of organizations that work together to, in a sense, better the community or address social issues in the community. And so my study looked at 175 of these types of organizations. And one of the things that I measured or talked to was the director of all these organizations. And so I gathered a bunch of data on the directors of these groups. And so then I need to explore the data that I collected. And so one of the questions I asked was, what is your race or ethnicity? So this was asked of each director, what's your race or ethnicity? And this is a categorical variable because there's different categories that they could fall into. The question would be, for descriptive statistics, is display the number or proportion of cases that fall into each category. And so there's a variety of ways of doing it. And so I'm going to show you probably 4 or 5 different ways to display the data. So the first is a frequency table, and it shows the number of cases that fall into each category. So the question is, what is your race or ethnicity? Total number of people was 175. And then here's the breakdown. 111 were white, 29 black, 29 Hispanic, 2 Asian, 4 other. So frequency is another word for number, in a sense. I mean, like, how frequent does white people show up in your sample, or how frequent is there black people in your sample? To me, sometimes it's a confusing term. It's like, isn't that a radio frequency or something? But really, in statistics, it's how frequent does this phenomena occur. A key statistic that we're interested in, especially in this course, would be the sample proportion. And this is probably a key thing to lock your mind on, because this will come up throughout the rest of the course. So we're looking at proportion, and right now we're looking at the sample proportion. Why would it be called the sample proportion?
You're not measuring every coalition?
Yes, so it's the proportion within our sample that we have. And that's important because we gather data on the sample, but then we make inferences about the whole population. And so we need to differentiate between the sample proportion and then what's the true proportion in the whole population. And this will get really confusing if you don't make this distinction, because you'll be thinking, oh, I'm just finding proportion. You'll try and have it be interchangeable, and it's not. So always look for, am I talking about the sample proportion or the larger population proportion? And so then the way it's notated, this is called p hat. Even as you're reading it, you can just sort of say p hat versus p. If you're wondering, what am I talking about? P hat, and it has a little hat. But it basically takes the number of cases in each category and divides it by the total number of cases, so you have the proportion for each category. Here's frequency table. The sample proportion of directors who are white, what would you guys say? Give me the fraction. 111 over 175. Good. So, hey, look we did that. 0.63 is the proportion, or you can say 63% of the sample is white. But basically, this is just sort of giving us a sense of the breakdown of categories of race. They can be used interchangeably. So what I showed you first was a frequency table. The next step up would be a relative frequency table. And it shows the proportion of cases, the relative proportions. So just as we did with the white category, we do the same with black, Hispanic, Asian, and other. And so what this does is gives you a sense of how big each category is relative to each other. Because sometimes if you just look at raw numbers, it's hard to know, is it 4 times bigger or 5 times bigger? And so this will give you a sense of, relative to one another, the proportions. And these numbers will all sum to 1. It represents 100% of the sample. The next way to display or visualize a categorical variable would be a bar chart, and this is probably familiar and similar. With each bar, it's almost, the best way for me to think about it is think of these as buckets. and you have a bunch of balls, and each balls represent the race. And so you hold up the ball and it says white, so you drop it in the white bucket and then you fill it up. And every ball is a person in your sample. As it fills up and the total number is 111, it just lets you know there's 111 people who are in the white category. And same with black, Hispanic, and Asian. Another way to visually display your data would be a pie chart. Basically, it takes the proportions and breaks them down. So these are just sort of quick ways for you to visualize your data. For you guys, what's more helpful? If I came up and I said, hey, I want to tell you about the breakdown of race of these directors that I'm studying, is this visually helpful in explaining sort of the breakdown of race? Or is this
Pie chart.
pie chart? Why?
Different colors.
Different colors, okay. That's good. Chelsea?
It gives actual percentages.
Okay, yeah. What were you going to say?
I just think
Visually.
I like that better than, I mean, they tell you the same information, but it's just more visually appealing.
Yeah. The reason I ask is every variable will have a different visual display that's more helpful. So even like the first example with the maps, with the map of the US, that was a visual display of data that was showing all the people, organizations that were sampled. And part of your research project will be giving a visual display of your data. And so it isn't just, which one's the right one to do. It's more sort of have an argument for why you chose to use a pie chart versus a bar chart. And really it depends on the variable. And we're going to look at other variables where it's actually more helpful to do it in a bar chart. But this is just sort of letting you know what's out there so that you can say, okay, I think it would look really cool this way, or be really informative, because the main idea is just to help explain your data. And this one is kind of interesting because it's like, wow, there's a lot more white people compared to all the rest. And I guess the pie chart does that too. So you just want to have different characteristics of your data stand out visually through the way you represent it. So then the next type of display of data would be when you have two categorical variables. And so you're looking at the relationship between two categorical variables. The two that I'm going to choose are race, ethnicity, and gender. So we just saw the racial breakdown of the directors. Now we're going to look at what's the racial breakdown by gender and by race. The way that you begin to explore this data is called a two-way table. And so the top row would be one of your variables, which is gender, and then the column would be your other variable, which is race. And it doesn't matter which one's on the row, which one's on the column. So if we were going to look at this, and my question was, what proportion of female directors are Hispanic? I want you all to write this down, and then I'm going to ask one of you to give me an answer. Or no, I'll have all of you do it. So what proportion of female directors are Hispanic? Someone want to take a stab at it? C. Okay, and how did you get that?
The total, what portion of female directors, so the total female is 81. The number of Hispanics out there is 12.
Perfect. So look, we're talking about female directors, so it's a subset of the sample, 12 over 81. So yeah, I think that's sort of a key thing about this. Like, when I first did it, I was like, okay, number of female Hispanic, 12 over 175, but that's the number of, what does that tell you? 12 over 175 tells you what?
Females there are
the whole sample. Yeah, that's good. So then, what proportion of Hispanic directors are female? Chris? A. So we do that. Boom, you got it. Good. Okay, so what's interesting is the proportion of female directors that are Hispanic does not equal the proportion of Hispanic directors that are female. And so the reason why I highlight this is you could be just, say this is a question on an exam, and you're just sort of reading through, okay, I got it, and boom, 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 you write down the answer. But just by switching the words around, I mean, it's all the same words in both equations, but they're looking at different subsets. And so it's just important to say, okay, what is the group that I'm actually measuring? So you don't just sort of make a dumb mistake just by going through too fast. And then we already did this, what proportion of directors are female and Hispanic, and that basically looks at female and Hispanic with the total population of 175 and be 12 over 175. Basically, using a two-way table helps you get all the data together to make an easy calculation of what the proportions of different subgroups are. Another way to look at two categorical variables would be a side-by-side bar chart. And similar to the first bar chart that we looked at, the height of each bar corresponds to the number of cases, but it also shows you, for the other category of gender, how it breaks down. So along the bottom here, you have one variable, which is race, and then you're comparing gender across each of the races. Another way to do it is along the bottom have gender, and then compare races across gender. The question for you as the researcher is to think, okay, what display gives the best representation? A final one would be called a segmented bar chart, and that just stacks it up on top of each other. This data is not particularly interesting on this level because the gender breakdown is pretty even. What thing do you notice, just by looking at this one, what do you notice about differences in gender by race?
The black and Hispanic kind of equal for female and male. They look like the same size.
Yeah.
Both sides.
Yep. Yeah, that's good. And whereas with the proportion of female Hispanic directors is smaller than the proportion of male Hispanic. When you're thinking about your research project, you're like, oh, wait, by visually displaying it, they'll be like, oh, wow, this is interesting. When you look at race in general, you're like, okay, yeah, white. There's a lot more white people than black and Hispanic. But then it could be, if you look at gender, you'll see something very different. Or if you look at gender and income or gender and education, you'll begin to see patterns that, okay, this is something that I should pursue or figure out, why is this going on? Then after we have one categorical variable, and then we look at the relationship between two categorical variables, and then the next is to look at the difference in proportions. So this gets kind of confusing, at least I think. So we have the difference in proportions for one categorical variable is, for example, the proportion who are Hispanic, and then calculate that for the different levels of another categorical variable, say gender. So difference in proportions is always working with two categorical variables. You can't have a difference in proportions for just race. I guess it can be a little bit confusing because you're thinking, oh, well, what's the difference between black and white? That's not talking about differences in proportions. What this is talking about is you take a variable like race, and then what's the difference in proportions across another variable like gender. I'll walk through this, but what is the difference in proportion of male directors who are Hispanic and female directors who are Hispanic? This is where we start getting into beginning to do math.
Yeah.
P hat. And then what do you think these two things indicate? Male Hispanics. So this is a shorthand way of saying the sample proportion of male directors who are Hispanic. And again, this is really important, sample proportion. And then P hat FH is the sample proportion of female directors who are Hispanic. Now, remember when we were calculating proportions, if we switch this around, if we said the sample proportion of Hispanic directors who are male, that's going to be a different proportion. So that's why it can get sort of confusing pretty quickly. So it's important to make sure what you're stating is actually what you're measuring. And then the difference in proportions would be male directors who are Hispanic minus the proportion of female directors who are Hispanic. So if we want to calculate this, what is the difference in gender proportions among Hispanic directors? So it's going to be this equation, which is also stated this way. The proportion of male directors who are Hispanic is going to be 17 over 94. And then the proportion of female directors who are Hispanic is 12 over 81. And then the difference in proportions is going to be 0.033. That's the basic mechanics of it, and this is something that we'll be using throughout the rest of this course. So it isn't just sort of like, oh, that's neat, but it's more so, okay, how did that work? Because this is going to be coming up over and over again, because often a question that you ask in sociology is the difference in proportions a significant difference? Is the proportion of male directors who are Hispanic significantly different from the proportion of female directors who are Hispanic? And so looking at this, does the difference in proportions, would you say that's large or small or small? In a way of thinking about it, it's the difference is about 3%, 3 percentage point. Whereas let's say it was the proportion of male directors who are Hispanic is really large and the proportion of female directors who are Hispanic is really small. Like, wow, there's a big difference amongst Hispanic, yeah.
Can difference in proportions be negative, or you will have to say?
No, so it can be negative, but it's just going to be the opposite.
Right.
So like if we flip this around, it would be negative 0.033.
Right.
So it doesn't matter. But I guess what matters is how you're framing your question. If your question is the difference in proportion of female directors less than male directors, you just want to make sure you have your signs right. This is how we're using the two-way table to calculate the differences in proportions. I would say, in a sense, after class, and there'll probably be an assignment on this, but make sure you understand this and how this was all calculated. So that covers categorical variables. Then the other type of variable is the quantitative variable. And it says, when describing quantitative variables, we're interested in the distribution of values. Any idea what distribution of values means?
It kind of, I don't know, I think of all those really good charts you look like, I don't know, the box and line.
The box plot?
Yeah, well, it just like shows, because like if you just take the mean of a quantitative variable, it might not show exactly what the data is telling you, because if you're talking about income, average income might be one number, but if you look at the spread of it, you might realize that certain factors are pulling that down or bringing it up. So it's not really the true average compared to technically it's a true average, but it's not representative. Yeah, it only tells you sort of one characteristic of the data. The distribution of values, if you have a field and the x-axis is some numeric value, it's sort of where are all the values distributed along that x-axis. In some cases, it could be all stacked on this side, and some it could be really spread out. But it's basically every respondent has a value for that variable. So if it's age, that's a good one. We'll say like in this classroom, how would the ages of you guys be distributed? Would it be all within one tight range, or would it be all throughout? A tight range, yeah. Whereas if we walked into the city of Durham, what would be the distribution of age values? It'd be all spread out. So it's basically how are the values distributed along the x-axis. But that's sort of a key thing to conceptualize, because this word will come up a ton, distribution of values. Again, because a lot of times when I think of distribution, I think of UPS or something in their distribution services and how they're delivering products, and it's like, that's not helpful. What's more helpful is how are the values distributed along the x-axis. And the key things that you'll use throughout this course is what is the shape of the distribution, what's the center of the distribution, and then also what's the spread of the distribution. And there's ways to measure each of those. So the shape is the form of the distribution of values. That's more intuitive. When you map out all the values, what type of shape do they take? The center would be basically the main peak where the most values are stacked up. And then the spread, this one's a little bit more confusing, relative deviation of the values. Can someone take a stab at what that's saying? The relative deviation of the values. If the values deviate a lot from each other, because it's relative deviation, so if they deviate a lot from each other, what is that implying? Yeah, exactly. So if there's, in a sense, a large deviation, that means they're going to be spread out. Whereas if there's very little deviation, like in this classroom, it means it's going to be really tight. And these are, again, the values of the variable that we're looking at. So for this one, we're going to look at data from the student survey. I'm going to show you about 4 or 5 different ways to represent quantitative variables. And the first is a dot plot. It's kind of like the bucket thing again. It's basically each person has one value for that variable. This question was number of text messages sent yesterday. So people could respond. The number along the x-axis is the number of text messages sent, and then each dot represents a person who fell into that category. Let's see, it's about 10 people in the sample sent 0 texts the previous day. This sort of gives you a sense of visually what's the distribution of the values. Another way of doing it is with a histogram. It's again sort of the bucket thing, but it's quantitative in the sense of different ways of visually displaying quantitative data. What I was going to say is, here it is. If you think about GPA, there's an infinite number of values you can have for GPA, and if you were going to plot it and you just took everyone's GPA, you would have one dot
for each of these different values, and so it'd be a flat distribution. You'd be like, well, let's combine these together. And so you'll often do this where you'll create categories. So you'll say, okay, between 2.6 and 2.8 is going to be one group. So any value that falls within that range, we're going to put it in that category. So you almost, in a sense, turn it into a categorical variable. But the main difference is that the intervals are all stacked on each other. So like with race, you have clearly distinct groups. Like you have white, black, Hispanic. With this, you have intervals. So if you fall within this range, you fall in this bucket. If you fall in this range, you're in the next one. And the reason for doing that is so you can begin to see how the grades are distributed. So this actually you'll end up doing a lot, because even if you think about age, you might say I'm 20 years old, but technically you're 20 years, 3 months, and 14 days. Or if you even go down further, you're 20 years, 3 months, 14 days, 6 hours. And so everyone would sort of have their own little bin. So what you end up doing is, okay, you round off to the nearest year. Same with income and a lot of other quantitative variables. This says you create bins or value intervals and place each case in the appropriate bin based on its value for the variable of interest. And then the height of each bar corresponds to the number of cases that have values falling within that interval. There's a difference between bar charts and histograms. Although they look similar, they're not the same. A histogram is not the same as a bar chart. A bar chart is for categorical data, and the x-axis has no numerical scale. And so this is an important distinction. With the bar chart, there's not a numeric scale on the x-axis. It's just the categories from your variable. Whereas with a histogram, the x-axis is going to have real quantitative values. For a categorical variable, the number of bars equals the number of categories. So like with the race variable, it was categorical, and you had 5 categories that you could fall into. And so that's the number of bars you're going to have. Whereas for quantitative variables, the number of bars or bins in a histogram is up to you. If it's in this class, I was doing age, I might say, I want to do year and months so that I can actually see some variation. But with a larger group, like Durham, I might say, let's do 10-year increments. The number of bars that I'll have will depend on how I set up the intervals. And again, a lot of this sometimes is just so that you can visually explore your data. So you can see, wow, it's very different. Depending on the number of bars you pick or number of bins, it's going to look differently. Just sort of a way to explore your data and see what's going on. Then the last thing is the shape. And so different distributions have different shapes. The first one, and this is sleep, how many hours of sleep do you get a night? And the shape is considered symmetric. And basically symmetric means if you found the center and what's on the right side is symmetric with what's on the left side. Whereas this distribution would be considered right skewed, and it's right skewed because there's a long right tail. And another way of thinking about right skewed is like, in which direction is the data stretched? And it's stretched out to the right, so it's being pulled out, so it's skewed out to the right. And again, this variable is exercise. How many hours do you exercise in a week? There's a group out here that exercises over 10 hours a week, and they're pulling the distribution out to the right. And the other thing would be left skewed, the data being stretched to the left. That's with GPA. And so a lot of times some of this is intuitive. It makes sense when you look at it this way. And it's also a good corrective. If you see your data and you're like, wow, that seems strange. Say this was flipped around, you're like, why does everyone have like below a 3.0? Like what's going on here? Something must not be right. It's a way to check your data. So we did shape. The next one is the measures of center. And there's a couple different ways of looking at that, and we'll watch a quick video on the wonders of the average.
As a statistician, the most well-used item in my toolkit is the humble average. It's the simplest but most powerful way to get a ready handle on a mass of confusing detail. What's so great about an average is that you can take a whole mass of data and reduce it to a single number. And though each of us is unique, our collective lives produce averages that can characterize whole populations.
I looked in my local newspaper one week and saw a pensioner had accidentally put her foot on the accelerator and crushed her friend against a wall. Devastating, hideous, horrible thing to happen. And then there was a second one about a young man who didn't have a driving license, was driving a car under the influence of drugs and alcohol, and He bashed into a pedestrian, killed him. What's remarkable, absolutely remarkable, if you look at the number of people who die each year in traffic crashes, it's nearly a constant. All these individual events, somehow when you sum them all up, there's the same number every year. And every year, 2.5 times as many men die in traffic crashes as women, and it's a constant. And every year, the rate in Belgium is double the rate in England. There are these remarkable regularities, so that these individual particular events sum up into a social phenomenon.
Let's see what Sweden have done. We used to boast about fast social progress. That's where we were.
In my lectures, to tell stories about the changing world, I use the averages from entire countries, whether the average of income, child mortality, family size, or carbon output.
Okay, I'll give you Singapore. The year I was born, Singapore had twice the child mortality of Sweden. It's the most tropical country in the world, a marshland on the equator, and here we go. It took a little time for them to get independent, but then they started to grow their economy, and they made the social investment. They got away malaria. They got a magnificent health system that beat both US and Sweden. We never thought it would happen, that they would win over Sweden.
But useful as averages are, they don't tell you the whole story.
On average, Swedish people have slightly less than 2 legs. This is because a few people only have 1 leg or no legs, and no one has 3 legs. So almost everybody in Sweden has more than the average number of legs. The variation in data is just as important as the average.
I think he has a cool voice, and it's very animated. From Sweden. He actually has a ton of these clips of ways to visualize data on a global national scale, which I think ends up being interesting when you're like kind of bored with statistics. So measures of center, and in particular the mean or the average, is going to be, again, a central theme throughout this course. And so understanding it and understanding how we're measuring it and how we're getting it is important. So I'm going to go through some quick notation. The sample size is the number of cases in the sample. It's denoted by small n, which we've already gone over. A variable is often denoted by the letter x, and then x1, x2, all the way through xn represents the n values of the variable x. So in this classroom, if you guys were a sample, what could x represent? Height, okay. Could x represent Rachel? Why not? Well, x1, so let's say x1 is Rachel, x2 is McKay, x3 is Timothy.
Rachel's height.
Yeah. Okay, and so then what would 1 be, what is 2, and what is all the way through n? What do those correspond with if this classroom was our sample? Exactly. And I think the reason why I make that distinction is really important, because these little denoters are going to be flying all over the place. And it's easy to think x is the person. Wait, no, x is the variable. Wait, is x the value? And what's the number 1? Is that the value? Or, and so x is the variable. We're going to be looking at tons of variables, and their variables are measuring a characteristic about the unit. And so the unit x1 is going to be the variable, let's say height, its value for the first person, which will be Rachel. So then it's important to kind of see that it isn't flipped around or other ways. The x is always the value of the variable for that person. So we can use an example. X in this case equals the number of body piercings. And then this first row is the first person. x1 equals 6, x2 equals 0, x3 equals 1. And so this is constructing our mathematical formula. The sample mean, and again, it's important to note that we're looking at sample mean versus the population mean. And then this is x bar, so the other one was p hat, so important to know that distinction, is the average. And it's computed by adding up all the numbers and dividing by the number of cases. And so here's the formula for how that would work. So x bar takes all of the values for the variable x for each person, adds them all up, and then divides by n, the total number in the sample. Any confusion on this in particular? Is that helpful or more? Yeah.
I like it.
You like it or it's helpful?
I like it.
Okay.
I'm very visual, so it helps me to see it like that.
Okay. It's probably more intimidating than it really is. And the key is just sort of breaking down, okay, what are each of these symbols representing? X bar is the thing that we're trying to compute. It's the mean value for all these cases. And then x1, again, is the value of, for respondent 1, of whatever the variable is. So this one would be body piercings. So that was all mean. Another measure of center, like the center of the distribution, would be median. And the sample median is the middle value when the data is ordered. It's basically the middlemost value. And I guess quantitative data is ordered, so it's going to be the middle one. So then even if there are an even number of values, the median is the average of the two middle values. And this is much more confusing than it needs to be. But basically, if you have a distribution of values and you count all the way into the middle, but if you have an even number of values, there's not going to be a true middle. There's going to be two that are in the middle. So what do? Well, you take those two values, you add them together, and divide by 2, and that will give you your median value. Median is a pretty easy one. I mean, there's no formula for it. You just sort of, oh, this will be good. We can do, what's the median age in this class? We'll start with Timothy.
19.
19.
19.
Gosh, you guys are going to make this.
18.
19.
Oh, this is beautiful. So the way we find the median for this, you might say it's 19 just because there's so many, but basically the way to do it, what's our sample size? 6. So n equals 6. So you go half of that, 1, 2, 3, and try and find the middle, but there is no middle because it's even. So it's taking these two values, adding them together, dividing by 2 equals 19. But it's counting into the center, finding the center, and that's going to be the median. And then another thing to be aware of when you're exploring your data is outliers. And an outlier is a value that is notably different from the other values. So like with this example, do you notice any particular outlier? 99? Okay. Let's see. Oh, good, you got it. That's an outlier. What about this one? Is this an outlier? That's like the highest line in this distribution.
Because everything over on that side is relatively high for the most part.
Okay.
It's the highest, but it's not like above and beyond everything.
Okay. And really, an outlier is going to be an individual value. So it's okay. I mean, it actually is sort of would be expected that you'd have a lot of values stacked together. It's when you have isolated individual values. So outliers are always going to be individual values that are different from the rest of the values, whereas all of these are kind of clumped together so they're not notably different from each other. Then there's a term called resistance. A statistic, so like mean or median, is resistant if it's not heavily affected by outliers. The median is resistant, the mean is not resistant. Another way of saying it is that the median value for a distribution is not affected by outliers. So even with the text messages, even with that one with 99 text messages, when you're finding the median, number 99 isn't going to affect the median. But it will affect the mean because it's going to pull the average number of texts that people send, it's going to pull it up. So if you look at it this way, number of text messages sent per day, if you include that outlier of 99 texts, the mean number of texts per day is 32.6. The median number is 8. Whereas if we took out that one value, 99, and said that was a mistake and we throw it away or something, and then we calculate the mean drops down to 9 texts per day. Whereas the median stays the same. What it means by saying the median is resistant, it's not affected whether the outlier is in or out. You know, if you're going to do a study on the number of texts that students send, it's very different to infer that they send 32.6 texts per day on average versus 9.2. You're going to be kind of like, well, which one is it? So then you need to investigate your data and go back and see why did that one person say 99, because that's really throwing off our averages. Dealing with outliers, When calculating statistics that are not resistant to outliers, look for outliers and decide whether the outlier is a mistake. So you can't just say, oh, 99, that's wrong, because that's maybe what the person does, and that needs to be taken into account. You could go back and look at the survey and see, oh, they really put down 9, but we coded it in as 99. Then you can fix the mistake. But if it's not a mistake, you have to decide whether the outlier is part of your population of interest or not. The quick fix for it is, for outliers that are not a mistake, it's best to run the analysis twice, once with the outliers and once without, and see how much the outliers affect the result. Then with measures of center, you have distribution of NHL player salaries, and these are their salaries along here, salary in millions. So here's 2 million, 4 million, 6, 8, 10. What's the shape of this distribution? Right skewed. Why is it right skewed? It's skewed to the right. Hey, that's good. So the values are stretched out in the right direction. So then if we look at, what is this telling us right here? Close. Median. It's good that we're going through this, because they might just put it up like this, and you're kind of expected to know little m means median. So this is the median value. They basically calculated that by just counting all the way till they got to the middle value, and there it is. And then what's this? Yes, oh, very good, sample average. So you see that the median is different from the sample average or sample mean. Can someone give an explanation of why X bar, the mean, is to the right of the median?
Because it's right skewed, so there's that, like, the 90, 14, 10 minute, and the average, right? Whereas the median number is like the actual middle of the data, so there's all those people who have less money, so that's cool.
Yep. If these values weren't out there and it was all clumped more towards the center, what direction would X bar move in? To the left. Yeah. So at a certain point, if the shape is symmetric, then the median and the mean are going to be more or less the same. It's a helpful thing to kind of know. You can tell just by looking at these two numbers whether your data is right skewed or less skewed or symmetric. That could be a question. I could just give you two values like this without even showing you the distribution, and I could say, what's the shape of the distribution? If the median and the mean are basically equal to each other, you could say, oh, it's a symmetric distribution. Or if X bar is to the left of the median or lower than the median, you'd say, oh, it's left skewed. Mean is pulled in the direction of the skewness. So then for the assignment, we'll look at part 2 real quick, but you're going to have an opportunity to gather descriptive data on your variables. Then I'll walk you through this. But basically using the same website that we've been using, what you've done before is just looking at the variable, look at the variable question. Now we can actually compute the mean or other descriptive statistics. So someone give me a quantitative variable. Age, okay. So you type it in right up here, age, so that's the variable. And then there's a couple of things you're going to want to click. Down here is summary statistics. We'll put in question text because that's an important thing. And then another would be over here, a bar chart. And you run the table. And so then what it does is it opens up, it's going to start by showing you all of the values that are out there. So then right here is the summary statistics. So what's the sample mean of the people in the GSS? The sample mean age is 44.32. Now the median is 42. So just by looking, I shouldn't show you this. So just by looking at that, what skewed is it? If the mean is 44.32 and the median is less, is 42. Chelsea? Right skewed. So it's weighted towards the right side or higher aged people. So then this gives you the visual display. And see, this is where this visual display isn't particularly helpful. What I think could be more helpful is if you put them into bins of 10-year increments or 5-year increments. I mean, this is just like overwhelming. So for the assignment, you're going to be providing, so for the quantitative variables, the mean, the median, and then the shape of the distribution. So you can look at it this way, and it shows you it's right skewed. And then let's do one more. Someone give me a categorical variable. Gender. So then same thing, and then you basically hit run the table. With categorical variables, we're interested in proportions. And so all that information is actually right here. And it's saying that in this sample, the sample proportion for males is 45.5%, whereas the sample proportion for females is 54.5. What's interesting, I've never fully figured this out, but they also provide the mean, but that's not really helpful for categorical variables. Because what does it mean that the mean gender is 54? It actually does explain to you that it's the same as the proportion. So that's what I want you to do for 3 quantitative variables. Find the mean, median, and shape. And then for 3 categorical variables, find the proportion. And type it up or whatever, because you're going to want to keep a running list. Yeah?
For the proportion, do you want just, like, do you want comparative ones or just one?
Just one.
One, yeah.
Yep. So I'm going to show one more. So this is an interesting one. If you look at the variable race, and you're like, okay, what's the proportion of race? And you pull it up, what do you guys notice about this variable?
A lot of the time, it's broken down into more races.
Uh-huh.
It's just like black, white, others.
Yeah.
It's like black, white, Hispanic.
Exactly. So this is where it's important to look at the data of saying, okay, wait, this might not be the right race variable that I'm interested in because I want to know about Hispanics and Asians and stuff. Very good. If you have questions, feel free to email me.